Okay, for Geometry 9.3, we are talking still about rigid transformations, but today it's all about rotations. So remember, a rigid transformation stays the same size and shape, but with rotating it, it just means we're going to turn it. So rotation has a couple of different T's in it, and the reason I'm pointing out the T's is because sometimes you call rotations a turn. And that should make sense because you're turning it just like a rotation of a clock or of fan blades or anything that you can think of that rotates. All right, here are the rules. So for a rotation of 90 degrees counterclockwise, let's make sure you know what that means. If I have a shape over here and I'm rotating it counterclockwise, that would be this direction. Now, if I rotate it only 90 degrees, it's going to end up in this quadrant. If I rotated it from here 180, it's going to be completely opposite down in this lower quadrant, which is diagonal from it. And if I rotated 270 degrees from here, 270, it would end up in the quadrant right below it. Here's something I want you to think of. A rotation that's 90 degrees counterclockwise, which is what I just talked about, would be the same thing as a 270 degree clockwise. So let's think about that. If this triangle starts here and ends up 90 degrees over here, let's say it just like this little pointed up part ends up being pointed over here. It is the same exact rotation as if I took this and went 90, 180, 270. It would end up in the exact same spot. It kind of looks like a little smiley face right now, doesn't it? So it doesn't matter if you want to do 90 degrees counterclockwise or if you want to go 270 degrees clockwise. That's a degrees. Those would be the same thing. And just like that, in the same way, if I had a circle and rotated it 90 degrees clockwise, it would end up here. Or if I went 270 counterclockwise, it would also end up here. So the same rules apply for 90 counterclockwise as 270 clockwise, and 270 counterclockwise is the same as 90 clockwise. So I hope that makes sense. Okay, the reason there's only one example for a 180 is because, let me draw one more picture. If I did a 180, it's going to end up here no matter which way I go, right? If you're thinking of yourself standing facing the front and you do a 180, you're going to be facing the back, but you could have turned over your left shoulder or you could have turned over your right shoulder, and either way you are going to be facing the back. So a 180, either counterclockwise or clockwise, is the same thing. That's why 180s don't say counterclockwise or clockwise. They just say 180. Okay, and the rule for 90 counterclockwise is these switch spots. So Y comes first and then X, and the Y becomes opposite. Okay, for a 180, I think this is the easiest one. They stay in the order XY stays XY, but both the X and the Y become opposites. So if this was 1, 2, it'd be -1, -2. Okay, and then lastly, the rotation of 270, which counterclockwise, which is the same as a 90 clockwise, would be these two flip-flop spots again, but this time the X is opposite. The Y stays the same. Okay, so these are a little tricky. I want you to keep these rules handy because they're going to help. All right, let's start on number 1 where it says rotate at 180. And again, it doesn't matter if it's clockwise or if it's counterclockwise because a 180 is a 180 no matter which way you go. I'm going to start by writing out the coordinates. So V is at 2, 0. J is at 1, -1. Y is at 5, -3. And then we've got R, which is at 4, -3. Okay, so what you'll remember, hopefully, from a 180 is that they stay in the same order, but they both become opposites. So V prime is going to be -2, 0. J prime is going to be -1, +1. Y prime is going to be -5, +3. And then R prime is going to be -4, +3. See how they all switched from negatives to positives, except 0, because 0 is neutral. So let's go plot them. So V prime is going to be at -2, 0, -2, 0. J prime is going to be at -1, 1. Y prime is going to be at -5, +3. And R prime is going to be at -4, +3. That's R prime. Okay, so I think my letters might have got a little bit in the way, but that's okay. Okay, so we just took this shape and just rotated it around, just like the blades on a clock, or the blades on a fan, or the hands on a clock, sorry. Okay, so number 2, we're going to try a little bit of a harder one. This is a 90-degree clockwise, and in case you forgot what that was, I actually gave you the formula, the rule right here. So let's write down what our coordinates are. So B is currently at -4, 1. X is currently at -3, -2. N is currently at -5, -4. Okay, here's what's tough. First of all, they flip-flop spots. See how X came first and then Y, but now we want Y to come first and then X. And not only does Y come first, but I want it to be the opposite of whatever Y was. So in this case, Y was +1. I'm going to write it as -1. And then that's going to stay -4. So the -4 flips spots, but it doesn't change to the opposite. Okay, so -2 is going to become opposite, so it's +2. But then -3 stays the same. -4 is going to become +4, but -5 stays the same, and I flip-flopped all their spots. So let's go plot them and see what it does. So B prime is going to be -1, -4. X prime is going to be 2, -3. And N prime is going to be 4, -5. Okay, I did that again where I kind of got in the way with my letters. Sorry about that. Okay, so what it did was it just rotated 90 degrees clockwise. So this part kind of swings around here and goes clockwise 90 degrees. Okay, the last two are actually done for you, so you don't have to graph them. I just want you to look at it and to tell me which degrees it rotated and what that notation would be. And again, the notation is just a fancy way of saying the rule. So what is the rule for it? So we know that P, I'm just picking out a random letter. Pick out one of these letters, and I can see P pretty clearly here. So P started down here, and it moved to P prime, which is in this quadrant, just to one quadrant back. So if you're turning one quadrant, that is a 90-degree turn. And if you're going backwards, it's counterclockwise. So our rotation is 90 degrees counterclockwise, which by the way is the same thing as 270 degrees 90 degrees counterclockwise. Actually, this is clockwise. I forget. This is clockwise. So I should not have put two C's. So 90 degrees clockwise. It's weird for me to think backwards is going the way the clock goes, but it does, doesn't it? It goes this way. So we went 90 degrees clockwise, which is the same thing as if I had gone 270 degrees counterclockwise. So the rule for that is XY becomes opposite, or sorry, Y opposite X. The reason I was getting a little confused is because it is the same one as this one. 90 clockwise is the same thing as 270 counterclockwise. So it is xy goes to y opposite x. Good. Okay. And again, you could have put or 270 degrees counterclockwise. Okay, let's look at number 4, last one. This one to me is an easy one because it started over here and it didn't stop at 90. It kept going all the way down here. And so it did here. My pen, using my pen would be better. So it's kind of pointing, if I use S as a pointer, so it's kind of pointing this way. 90 would have been up here, but it kept going and it ended up being a 180. So if it exactly switched to the opposite, it did a 180. So a 180, and again, you don't need to put counterclockwise or clockwise because it doesn't matter. And the notation for a 180 is x comma y changes to opposite x, opposite y.